Okay, why don't we get started, everyone? Thank you for coming today. My name's Arjun. I'm a developer advocate at Pinecone. Today, I'm going to be giving a presentation on how to go from zero to semantic search with Pinecone's developer MCP server, Cursor, and Claude Code. So if you're out there, you're using an IDE, maybe an IDE that has like AI assistive coding inside it, like Cursor or Claude Code, and you're like, I really want to build with Pinecone. Today's webinar is going to help you figure out how to do that. We're also going to learn about what the MCP server can do in general. So if you want to integrate it into your applications directly, you'll be able to take away something from here as well. Let's get started. So we're going to start with a quick introduction to what MCP is. I saw a few questions in the chat, so that'll be great. We'll cover our bases there. We'll talk about the different MCP servers that Pinecone has. We actually have 3, but today we're going to talk about the Pinecone Developer MCP. Then I'll show you how to set up the MCP server in 2 really popular IDEs, Cursor and Claude Code's technically not an IDE, but I'll show you how to use it inside Visual Studio Code using Claude Code. Finally, I'm going to show you a live demo with live agentic generation on using the Pinecone MCP server inside Cursor and inside Claude Code for developing a sample application. Yes, Sahin, the Claude Code demo will be in Visual Studio Code, so I'll show how to use that as well. But before we get into what MCP, how we can use MCP, we kind of have to talk about what MCP is. Now, for those that don't know, MCP stands for Model Context Protocol. And what it is that it's basically a standard for retrieving context from various different tools and services to your applications, like IDEs or like AI applications or scripts. And yes, I see a bunch of questions about Windsurf. You should be able to install the Pinecone MCP wherever you can use an MCP tool. And that's because the MCP protocol is written to standardize access to a wide variety of tools that support that protocol. So you might be thinking about using a variety of tools with your LLM applications or inside your applications directly. And you might be like, oh, I want to use Pinecone. I want to use a custom tool that I've written. I want to use all these things. Maybe I want to grab like information about the weather or do code search or internet search or what have you. You would normally have to wrap those tools in your own functions and then wire them to your application in a really custom way in order to get your AI to access them. But with MCP, they've created a standard so that every tool can adhere to that standard, and then adding a tool becomes seamless. You can just add a tool that supports that standard. You don't have to think about the implementation details in really specific situations. On top of that, there's a lot of generalized information about those tools that can be standard. And yes, people say, and the docs for MCP actually say that it's kind of like a USB-C port for AI applications. Now, not only can you use MCP supported tools like inside your clients, like if you're using Claude Desktop, like if you're using an IDE, like I'm describing Cursor or Claude Code, but you can also use MCP servers in your apps yourself. So if you have like LangChain or Llama Index and they support an MCP integration for a set of tools that you have deployed on a local server, you can access those there as well. So it makes it easier to kind of build these types of agentic applications. Now, what about Pinecone's MCP? So what's cool is we actually have 3 different MCP variants. We have an MCP client that is remote. We have an MCP client that is local. Both of those have to do with the Assistant MCP. If you aren't familiar, the Pinecone Assistant is our like low-code RAG tool where you can upload a bunch of PDFs to Pinecone. We'll chunk them, process them in a really optimal way, and then you can start doing retrieval augmented generation over those chunks using the Assistant. But sometimes instead of having the generated output returned, you might just want the most optimal chunks that we're kind of returning under the hood. And these MCP servers will let you return those chunks directly so that you can integrate them into your own custom application. Today, we're going to be talking about this 3rd block, which is the MCP client that has to do with the developer MCP. And that connects directly to your Pinecone indexes and database operations. So I'm talking about these set of operations. I'm talking about listing your indexes, describing them, creating indexes, upserting, searching, and looking at the documentation as well. So cool, that's awesome. But like, why should I care about what the Pinecone MCP does for me in Cursor or Claude Code if I can just like write the code myself, or if I can just like go on the console or something like that? Well, it turns out that if you use the Pinecone Developer MCP, it will give your agents inside your IDE that you're using to code context about what your Pinecone indexes are doing. Because if you think about it, if you don't use the MCP server, you have to inform your agents what data is inside your indexes, how you're querying your indexes, whether they're live, how many vectors are in there, whether upserts are successful, all of that sort of stuff. You're not going to have context about it unless you have a record of running an upsertion script or something of that sort in your IDE, which most people might not intuitively have. So when you have the Pinecone Developer MCP kind of hooked up, you can dynamically look and check these things. So you can imagine a situation where we might create some data, we might run an upsertion script, and then we want to know if that upsert was successful without navigating away from our IDE. We can use the Pinecone MCP to say, hey, can you check this index, see if there's any data in there? There is, that's awesome. Okay, now I want to search over that index. Normally, you would have to write like a search script in order to embed your data and then search over. With the Pinecone MCP, you can just command your agent to pass in a set of queries, and it'll return those results for you. So you can, like I said, you can create integrated indexes from Pinecone hosted models, generate data, upsert them, search over the docs to generate your scripts, get the most up-to-date information so that you can write in good scripts, so on and so forth. Basically, if you're trying to learn Pinecone and you're trying to test your Pinecone code in a really simple way, the MCP server gives you a way to do that, especially if you're already using agentic coding. What it's not meant for is heavy upsert workloads, especially inside the IDE. So we're not going to be seeing like 1,000, 10,000 vectors or text being uploaded via the developer IDE part. It's not going to replace scripting entirely in that sense. And we won't be able to work with indexes. We won't be able to check the status of it. We won't be able to work with indexes that don't have integrated embedding in them. And what that means is that if you're using a third-party embedding model with this specific MCP server, like OpenAI or Cohere or like your own Hugging Face embedding model, you won't be able to interact with indexes created with those. But if you have an embedding model that is one of the Pinecone hosted ones, you'll be able to integrate with those pretty easily with the server. So what tools are available in the MCP server? Everyone knows that MCP server comes with tools, and those are the things that your agent is able to do because you've connected to that server. You can search over our documentation, which is super handy when your agent spits out outdated code and you kind of want to double check against that. You can do index operations like listing the indexes you have, describing the indexes, so understanding what the configuration of that index is, checking what's inside that index, that's a describe index stats operation. You can create indexes from the MCP server. So if you're just getting started with a project, you can be like, hey, make me an index and you're ready to go. You can upsert a small amount of data through the MCP, which is really helpful if you're trying to test if the index is working as expected. You can search over your index. This is the most helpful one for me. Sometimes when I upsert a lot of data, I just want to search over it really quickly, and I don't really feel like writing the search script myself and then running the script and then kind of making it easily accessible via the command line. I can just ask the MCP server, hey, do this search, hit it with this index, tell me what's kind of coming out. You can even do a cascading search if you have multiple indexes set up. And you can re-rank as well. And again, I want everyone to keep in mind that this is really only supposed to be used for indexes that have integrated embedding inside. So if you're using our Llama Text Embed v2 model, our multilingual E5 model, our Pinecone sparse model, that's what you want to be doing here. Okay, so how do you set these things up in your IDEs? In Cursor, you can follow the instructions on the screenshot. You'll need a Pinecone API key, which will just get you access to your project, basically. And this will work on the starter tier as well. So you can just get a free API key and get started and going. You can add this configuration inside the settings inside Cursor, check the status, and you're pretty much good to go. For those that aren't familiar, Cursor is an intelligent IDE, integrated development environment, that has built-in auto-completion and even some agentic capabilities. So it makes it super easy for you to customize the information that you want to be working with when you're generating code. Cool thing about Cursor is that it's an MCP client, which means you can connect multiple MCP servers to Cursor. You can even index your own set of documentation and web URLs and search over that when you're trying to generate code. MCP server inside Cursor is really useful for accessing information about your indexes and kind of developing with them. What about Claude Code? For those of you using Claude Code, it's basically an agentic coding tool. It lives in the command line. There's also an integration inside Visual Studio Code, which is what I'll be showing today. You can add the MCP server to Claude Code in a really similar way, where you kind of just say add JSON, put in your API key, and kind of run this right before you launch Claude Code. And then you'll be able to check the status of your code as well, of your integration as well. What's nice about Claude Code is that it doesn't have the auto completion like Cursor does, but it offers a lot of flexibility and control in agentic workflows, a lot of customization for how you'll use these tools and how often you can run them, all that sort of stuff, which some people like a lot more. So what are we going to demo today? I have a fun demo for everybody today. We're gonna get our thinking caps on. We're gonna pretend that we're developing a Streamlit application specifically for a new neighborhood snack company called Search and Snack. And what Search and Snack does is they have a bunch of savory snacks and a bunch of sweet snacks, and every single one of those snacks has a text description which we're able to search over and which we will embed in our Pinecone indices. What they've asked us to do is build a snack recommender application where people can put in what they're craving, and it'll return a set of recommended snacks that you would like to eat. So I might roll up and say, look, I'd love something salty that I can kind of munch on while I'm watching TV. And hopefully, the way our embedding models work will return information about foods that will kind of match that description without necessarily thinking about the overlap between the description and the actual words I'm using. We'll be creating a dense and a sparse index though, and we'll re-rank over them so that we can leverage both keyword search and dense embedding search at the same time. So we can understand the intentions of what people want in addition to the words that they're using. If they specify a specific ingredient, we'll be able to match that. All right, I'm gonna show you how to do half of this development inside Claude Code first, just to get you a feel of how Claude Code feels using the MCP server. And then I'll show the rest of the development inside Cursor. In Claude Code, we're going to create a dense embedding index inside Pinecone with our MCP server. We'll generate sample food descriptions for our store, and we'll upsert a subset of them using the MCP server. So we won't be writing code at this point. And we'll query the dense index in order to verify that the records have been upserted. So we'll be able to test to make sure everything's kind of working. We'll use claude.md files. These are Claude memory files in order to spec the type of development that we're doing. And I also should point out to everybody that I've already written the Streamlit application. We're just loading the indexes and kind of working with them here in the demo, which is something that somebody might do. You might scope out what the application should do, but then you might be working on upserting that data. We're going to figure out how to upsert that data. So once we make the dense stuff inside Claude Code, yes, MD is Markdown. We'll go to Cursor and we'll create a sparse index in Cursor with a Pinecone MCP. What that means is we'll create an index with the Pinecone sparse model, which is basically a fancy form of keyword search. We'll try to generate an upsertion script using the search docs functionality. So we'll pull in the most recent information from Pinecone and generate an upsertion script, upsert all of our data, and then we'll try to query it inside the agent as well to see if that was successful. After we do that, we'll run our application, we'll run a couple queries, and we'll see what's what. We'll be using Cursor rules in order to structure our development, and I'll show you the rules that I've written in order to make it possible for us to do these operations inside Cursor and Claude Code. All right, everybody, it is the most exciting time of the presentation. Now we're gonna go into the demo. However, I have some disclaimers and some warnings for you. This is a live agentic demo, which means I will be typing in commands and there is a non-zero chance that the scripts that will be generated might not be exactly what we need. And that's okay. We have the time together today to figure out what we need to be doing exactly and how that should be generated. And I also have backups just in case we need to kind of keep moving forward in the presentation. The MCP server is something that you can use today, but if there's something about it that you'd like us to update or change, we want to hear that today so that we can get to working on that. So if we're ready to go, I'm going to go ahead and start sharing my Claude Code screen and we'll get started. By the way, if you have any questions, we'll be answering those right after this portion of the presentation. Please put them in the Q&A section of the presentation so I can answer them. I'm going to go ahead and stop sharing my screen and I will share my other screen in just a moment. Thanks for sticking with me, everybody. This will be a lot of fun, I promise. And maybe you'll learn a thing or two along the way, too. Alrighty. Okay. We're here, everybody. Can you see my screen? We doing good? Awesome. So I've created a fresh environment inside my Visual Studio Code. And I have no indexes, but I do have my Claude Code instance kind of set up here, which is awesome. First thing I'm going to do is I'm going to check the status of my MCP servers. So I'm going to hit /. I'm going to hit MCP. And we can see that we're connected right there, Pinecone MCP. Now let's go ahead and view the details. We're connected. We're using NPX. We have a bunch of tools. Let's see the tools. Search docs, list indexes, describe index stats, create index for model, upsert records, search, re-rank documents, blah, blah, blah. You get it by now. Let's take a look at one of these, search index. That lets us look at what indexes we have. So why don't we start there? I'm going to go ahead and ask Claude, hey, Claude, what indexes in Pinecone do we have right now? Claude's going to burr a little bit, and look at that. We got our tool use almost immediately. Pinecone MCP list indexes, yes. And we have no indexes, which means we're ready to go. And the second thing I want to show you is my Claude MD file, which Claude picked up here right now. You currently have no indexes in Pinecone. According to your config, you're planning to create 2 indexes for search and snack recommendation systems. Dense index, snacks dense with namespace snack descriptions. Sparse index, snack sparse with namespace snack descriptions. The reason why Claude knows this is because I've created this MD file right here with what we're doing. And the way the Claude.md files work is that they're automatically injected into every command that I give Claude. And inside here, I've described what we're building today. I've described that we're making the simple search application, that we have items, that they come in 2 categories, savory and sweet, and that each of these items should have certain specifications, so on and so forth. And I've added a bunch of details about what the record should look like, all that sort of stuff, which I'll get to in a moment. But first, we're going to start creating the indexes. All right, Claude, let's start. Please only create the dense index with llama model and report back to me. Let's see what our agent comes up with. All right, cool. Create index for model, name, snacks dense, embed llama text embed v2, which is the model that's hosted on Pinecone. And we can just go ahead and create it. And how did Claude know that we were doing this? In the bottom of this Claude MD file, I've specified what the configuration should be. So all Claude had to do was read that and process it. So let's go ahead and create those indexes. It'll take a few seconds for the indexes to be created. And look at that. If I click Command R, we can see that we've created the index, which is perfect. Yep, this is awesome. Awesome. Thank you. The next thing we will do is create some sample data. Could you look at Claude MD and our other file, which is going to be generating data, because like I said, we don't have this data. We need to generate some in order to actually start doing semantic search. To generate a sample of 30 data points. After you do this, write them out to a JSON-L file called snacks. To show you how I've specified the data generation, we can go over here and click on my little text file, which says you are tasked with generating creative and enticing food descriptions for a recommendation system. Users will request foods based on their preferences, and your goal is to provide descriptions that are either match sweet or savory categories. Each food description will have 1 or 2 sentences, and it'll have metadata that indicates whether it's savory or sweet. And I have examples here of what that will look like. And the other thing I want to show you is I've not only done that, but I've included a records example of what the data should be formatted like. So if you see here, I have records example. I have 2 rows. I have IDs, which have to be in every Pinecone record. I have text, which is going to be the description we're embedding. And I've shown Claude how the metadata should be embedded like this. This will help Claude correctly format that data. The final thing I want to show you is inside my markdown file, when I'm talking about generating data for the application, I've used the @ symbol to pull in these other things that I've described and the records JSON, in addition to how I want Claude to be working with this data. That will ensure that the generation is correct. Now, this is perfect if you have no data and you want to just test a small amount of data that you know the schema for. All right, so let's go ahead and see what Claude will do. So we've read in these 2 files, which is great. It's starting to generate the data. This is going to take some time because we're literally generating the data, so it'll stream the information back to us. After we do this, I'm going to ask Claude to upsert a subset of the data, and we'll practice querying it to make sure that the data look like what we need to, and that the querying kind of does what we expect it to do. Hi, Raj. I haven't uploaded the reference materials just yet. I was going to do that based on interest in this webinar. So if this is something that you'd like to see, I will make a repo where you can just pull everything, have the environment set up for you, and you can replicate what I'm doing. Awesome. Just a reminder, everybody, this markdown file is Claude's memory file. Okay, cool. Let's take a look at what Claude generated for us. Oh, yeah, that sounds delicious. Crispy bacon wrapped jalapeno poppers stuffed with cream cheese and sharp cheddar. Amazing. We got names and we got categories and we got 30 of them. Beautiful. This is exactly what we need. We're going to go ahead and say, yes, please. And we got that data generated. That's awesome. All right, we created 15 savory snacks, 15 sweet snacks, and everything has an ID, and we used our guidelines. This is perfect. Awesome, Claude. Now let's test upserting our data and querying it. Please upsert the first 5 entries from our JSON-L, and please query the, please upsert from JSON-L and report back. Now what Claude's going to try to do is call the upsert records function using the first 5 entries from JSON-L. Now I want to kind of talk about a subtlety here, is that based on how Claude is using these tools, it's going to read in this information, but it's going to generate the appropriate call to the upsert function and then upsert that. The reason why this isn't great to do for like 100 entries is because Claude's going to have to generate like a really, really long function call, which is not ideal. So this is good for testing. It's not good for like if you have 100, 200 entries, you might run into some issues. So we can see that we're going to upsert this here, upsert records into name snack dense, namespace snack descriptions, and we have the list of records here, which is awesome. I do want to proceed. Data was upserted successfully. That's awesome. Now, sometimes when you upsert with integrated inference, it can take a few seconds for the index to reflect that update. And Claude even told us what was upserted. Let's double check. Bacon and Chipotle. Go over here. Bacon through Chipotle beef jerky. That looks about right. Awesome. Awesome. Let's check the status of our index we just created. And notice how I'm doing this entirely just interacting with Claude. Like I don't have to write any scripts to actually do this. Okay. Awesome. Our data's in there. We did it. Let's query for something. I'm craving something fried. Now I'm going to run a query, see what Claude is doing. Search records, query, top 3, because there's 5. I'm craving something fried. Let's see what comes back. Herb crusted mod sticks. I can't have any dairy, but if I could, I'd eat an herb crusted mod stick. I don't know about you all. Bacon jalapeno poppers, also fried. And then we got the brownies. We got the brownies back because we only have 5 data points, and this is not as relevant as you can see as the other entries. That's pretty good. Cool. And that's what we wanted to do with Claude. So what I'm going to do now is switch over to our cursor instance where we'll upsert the rest of the data and then actually interact with our application. So if you give me a moment, I'm gonna go ahead and hit stop share. I'm gonna double check my checklist here to make sure we went through all of these steps that we need to. Yeah, if you have a lot of data, what you want to do is generate an upsertion script, which I'm going to show how you will do in the next in the next little screen share I'm about to start. All right, everybody, we are inside Cursor now. You can see I have a few things open here. I have my Cursor rules that are visible on this left side here. I have my past chats. We don't got to look at those. Don't worry about it. And we got the chat functionality in the right here. And I've opened agent mode and I'm using Claude 4 Sonnet. When you're setting up the Pinecone MCP server, you want to navigate to Cursor settings. You want to go to tools and integrations and you want to hit new MCP server here. So if I hit this, I'm going to get the config, which I can kind of add manually, which was those instructions I showed prior. But we've already set up Pinecone here and we can see we have access to these tools directly here. So we can actually toggle access to these tools by clicking on them. So if for some reason you're using an agent and it has a particular affinity for like calling re-rank all the time, you can just like turn it off and it'll no longer be a problem. And if we hover over these tools, we can see their parameters and the descriptions for their parameters. So that's pretty cool. And this little green symbol means that everything is a-okay. I'm going to go ahead and close this. The next thing I want to show you quickly is how I've set up my development environment so that I can use Cursor to the best of my ability. The first thing I've done is created a project spec.mdc file. MDC files are special Cursor files. I think they're called Markdown something. There's like a specific formatting for them that you can give a description for, and you can give an always apply for, which determines when they're injected into context. So for my project spec, I want that in every call to the LLM. So I've made it always apply true. And this is basically the same Claude Code file that I copied and pasted. And what's nice is that it works in a similar fashion, where if I have an @ symbol and I wanted to pull in some information, it'll be able to pull in that information. One rule that I've included here is that if you're upserting a lot of data, you should write an upsertion script and you should figure out how to do it by searching over the Pinecone documentation. And I also have my configs here as well. Next thing I want to show you is a rule file that I've created for using the Pinecone Developer MCP server. This is something that is a work in progress. We're still iterating on this to figure out exactly what the best way is to instruct these agents to use the Pinecone Developer MCP server. This is what I've written specifically for this demo, which might not meet your requirements. If there's something that you're using the MCP server now, or you want to use it for something in the future inside an IDE that you'd like to differ from this, please let us know and we'll include it into a file that we can share on the internet. I have some explanations about what the MCP tool is, what context it covers, and how you should be using some of those tools. I also have information here and guidance about what should happen if I run into errors, how I can gather more information about it, so on and so forth, how to install Pinecone, not to use certain old clients, all that sort of stuff. Finally, I have a rule file for what the upsertion script should look like. You probably don't need this if you're trying to do development by yourself. I just did this because it makes it easy for me to just add that and tell it to make that file instead of having to type a really long description in this live demo. But you can see that I've basically told it to create an upsertion script to follow the other documentation that I've written, and that it's going to upsert into both of the indexes we were going to create, the sparse and the dense one, at the same time. Awesome. I've done a lot of talking, but we should do some coding now. So I'm going to go ahead and say, hello, we need to continue coding in this environment, and we need to create a sparse index in Pinecone with our for our data. Using project spec, please create the sparse index using the MCP server. Then report back for further instructions. Use the Pinecone sparse model. So I'll go ahead, issue that command. It's going to think a little bit. It's going to think hard. It's going to take a couple seconds. And it's going to show me the tool that it wants to call. Snack sparse, field map text using Pinecone sparse English v0. That's perfect. Let's run that tool. I like running in approval mode because I want to make sure that the tool calls are correct, right? Okay, great. We've created the index, which is awesome. And it's telling me a bunch of stuff about what it wants to do next. I'm just going to interrupt it and go ahead with my next command. Awesome. We need to write an upsertion script for Pinecone that will take snacks JSON. Oh, you can see I have a little live demo insurance file which contains the stuff I need, just in case if things blow up. But let's hope cursor kind of catches my drift here. So we need to take the snacks JSON-L file, upserts it using Pinecone's Python SDK into our indexes stack dense and snacks sparse and snacks dense, snacks sparse and snacks dense, and then reports on the records that are there. Please use the upsertion script spec to write the script. Make it as simple as possible and easy to run with UV in the command line. Assume my environment is set up. All ready for running the script, which it is. Finally, there's one more thing I want this to do. Use the search docs tool to understand how to upsert data for integrated inference in Pinecone in Python. All right, everybody, let's double check that we have the context that we need. Oh, call the script upsert snacks.py. Okay. First, we're going to search for what the best practices are in our documentation. We're going to get a bunch of stuff back. We're going to talk about integrated inference here, which is awesome. Like I said, sometimes the search functionality can be a little weird, but we'll work through it. And if it doesn't work, we got a little backup. Awesome. So it's going to start to cook. And just a reminder, everybody, when we talk about dense embeddings, we're talking about semantic search, which allows us to represent the entire intent of what a user wants or is thinking about when they're conveying or writing their query, irrespective of the words that are being used. So it's kind of like understanding the meaning of the user's query and then looking for the descriptions that would match that meaning. Whereas with keyword search or lexical search, we're really focusing on the words being used. So if somebody says, hey, I want a chocolatey an item, then we might look for descriptions that have the word chocolatey in them or chocolate in them. Awesome. So we've run the script. I'm not going to make it run it because I'm going to run it myself. So we'll just kind of reject here and we'll take a look at what the script looks like. Let's see how we did. Let's see if this is up to snuff. Okay, cool. We are importing Pinecone correctly. We're reading the data. Looks fine. Dense name, sparse names, namespaces. That's correct. For index name and blah. Upsert, try, create the index. Put in the records. Yep. Check the index stats. Oh, hold on. Are we? Nope. We're just getting the connection. That's great. And then we're gonna try to check the indexes. We're gonna check index stats. Let's see where this is being defined. Yep. Okay. This looks fine. Let's see how it works. I'm gonna go ahead and keep that. I'm gonna open my terminal here, which I've already instantiated my UV environment with. I'm gonna hit a little script here that I've saved. Here we go. UV run upsert snacks, which is this file, and I'm going to point it to my end file, which I will not be clicking on this webinar, and we'll see if that go ahead and works. Okay, let's loading the indexes, upserting this next dense, next smarts, waiting for it to complete. Awesome. So it looks like we were able to do that successfully. That's awesome. We did it. But how do we know that we actually did it, right? So let's interrupt this for a second and say, awesome. I ran the script. Can you check our indexes and see if the 30 records are there in each? Do that and report back. We'll wait for the magic box to think a little bit. Okay, describe index stats, and we have our records there. We did it. It worked. And we're going to call this again. And we have our records there too. Awesome. Yay! Woo! We did it. Awesome. All right, last step. Let's try to do a cascading search across them using our MCP server. Cascading search for the uninitiated is our Pinecone term for hybrid search, which is when you have a dense index and a sparse index. You search across both of them, re-rank, and then return the results. It's a way of kind of getting the benefits of a dense search or a semantic search and a lexical search at the same time. So let's look at this call. We got the indexes specified correctly. We have our query, and then we have our re-ranker, which is the free re-ranker under the starter tier, the BGE re-ranker. Let's run it. And what did we get back? Oh, that's funny. We did get our results back. Wonderful. Let's see. We got white chocolate raspberry truffles. That's awesome. Dark chocolate peanut butter cookies. And okay, let me ask one more thing. This time, I want something spicy and fried. Here we go. And I want to see if we actually end up using these actual keywords inside the indexes. Let's take a look. Fried dill pickle chips, spicy dill pickle chips. That's pretty awesome. Cajun spiced, right? That's a different little word. We're using paprika and cayenne, which is kind of what I'm looking for. And of course, the moz sticks. Wonderful. So we did what we needed to accomplish today. Let me show you what the application we were trying to build looks like here. I'm going to go ahead and pull out our app, and I'm going to go ahead and run it, because now it has access to the indexes we need. So let me go ahead and share that portion of the screen. Boom. Let's try, maybe not burn my taste buds. Maybe that was a little challenging. Let's try really crunchy. Boom, wasabi peas and almonds. Amazing. There you have it, everybody. We were able to build our application, load our data into our indexes without writing too much code and kind of letting our IDE do the heavy lifting. I'm going to share my screen for one final time. We're almost done here. Oops. Sorry about that. All right, we did it. We're done. That's the demo today. That's how you can use the Pinecone MCP server. And now it is time for the Q&A. Let me know what you think. I'd love to hear what questions you have about how the Q&A works. and we'll get started. Neeraj is asking about the recording. We will be sending it out after this. You'll be able to see the entire recording, and it'll also be on YouTube as well. Nick, you are asking the following question. When you want to utilize both indexes, the dense index benefits as well as the sparse index benefits, for a data set of multiple million records, would you need to build the indexes twice? Depending on the kind of hybrid search that you'd like to implement, you will need to have either separate indexes or what's called a sparse dense index, which both of them are kind of in one, which is kind of a separate benefit. Our recommendation is to have these separate indexes. But the thing is, you don't have to hit everything inside those indexes. You can specify the number of results that you're kind of returning. And you can also determine when you want to hit those indexes depending on the user's query. So you could do some sort of query routing and be like, okay, this user is clearly looking for really specific ingredients. We're just going to hit the sparse index. Oh, this user is looking for like this other thing. We're going to hit the dense index. Or we really need to hit both and kind of return those results. Vince is asking, when indexing any content, if we also add semantic search related to the content, would it help to become more intelligent when getting vectors? So semantic search is a way of embedding your data or vectorizing your data so that you can kind of pull out the concepts that are represented inside that data. So if you have like an existing data set and you're using keyword search and you re-embed it with semantic search, the types of questions and the queries you'll be able to support are going to be different than the types you'll be able to do with a normal lexical search. So in that way, your search will be more intelligent, but it'll be different kinds of queries. You might need to use both kinds of search to support the exact things that your users need. You just have to see what types of things people are asking and whether that will really work well. How is improper output handled in the context of usage? Gabriella is asking, can it be automated? You can instruct your agent to like repeat in order to keep calling the MCP server until it resolves the issue. But at some point, you probably have to intervene and be like, hey, this is not the thing that we need, or hey, you need to adjust the context that you're kind of passing to the model in order to generate the correct thing. Let's see. Vince is asking, what is the main difference between the sparse and the dense index? Which is faster when retrieving the indexed vectors? That's a really good question. I don't know if the embedding model is going to be the bottleneck when you're querying either of these indexes. I can find that out and get back to you specifically. For the dense index, you're technically embedding with a dense embedding model, which will add a little bit of latency, and then you're querying the index. With the sparse model, the way that the search happens is a little different. I wouldn't be as concerned with the speed of the indexes when you're thinking about dense versus sparse. I'd be thinking about the types of queries that you want to support. So if you want to support queries that are like natural language questions, like, oh, how do I find this document? Or how do I do this thing? You probably want to use dense. If you're going to be supporting queries that are really technical, that rely on the user already knowing the vocabulary that they're going to be looking for inside the index, you want to use a sparse method. Chi is asking, in the last and final query, you ran for looking for something spicy and crunchy. You didn't need to reспecify to run in the compound search to Pinecone because your prior query already specified compound search between sparse and dense. I pre-made the Streamlit application to hit both of the indexes. I'm not doing any routing in the Streamlit application. That's why we were able to kind of return both results there. Okay.
Hey, Arjun.
Yes.
I'm marking a couple as answering live. So like Bruce just asked, I'm interested in creating a knowledge base of business documents in Pinecone and to use Claude to access via MCP. Do you want to answer that one?
Yeah, that is a great question. So, what we would need to do differently from what you did in this demo. So, depending on what format your documents are in, you might be interested in using the Assistant MCP because the Assistant MCP will allow you to you'll be able to create the assistant outside of the MCP server, but you'll be able to retrieve context from like your PDFs or your business documents through the MCP server. However, that will not let you write back to the MCP server as far as I am aware with the assistant. If you want like write abilities and you want read abilities, the Pinecone developer server will be helpful to you. Although I want to caution you against using the Pinecone MCP server for like your complete write workload. So if you're writing like really small amounts of data, it's probably okay. But what I would do is have like a scripting capability where you're like, hey, all of the files that are in this folder locally, whenever a new file is added, recall this script or rerun this script, and that'll embed all of these things and kind of keep them in sync with Pinecone. That's probably what I would do in order to make that happen. and you're probably going to need to write some code in order to pre-process those documents into chunks in order for them to be upserted in the first place. So that's what I would think about, Bruce, when you're developing that application. Great question. Let's see. Chi, I went ahead and answered your question here. Eric says, when using Pinecone N8N, we've been encountering duplicates in the database, which has affected responses. Any idea what could be the issue? You might be upserting with like different IDs. I'm not super familiar with how the N8N integration is because N8N maintains it, we don't maintain it. So I'm not super sure what's going on there. But if you're running into a lot of issues with that, raise it inside our community and we'll look into it there. I went ahead and answered Vince's question, your other question as well. Next question's been answered too. Can you ask something like, surprise me with the top 3 snack choices of today, essentially without specifying anything? So the way that the search works is that we're just matching against the descriptions and the user query. So if we ask a temporal query of like, how often have people chosen a set of snacks and like that metadata, that isn't even in the index because I haven't generated that. So we wouldn't be able to answer this type of question. That's actually a great example of what we wouldn't be able to support with the current implementation. Now, if we had metadata of like, hey, this is how many times this snack was shopped, we could use that in order to structure our search based on that day to day. Yes, Nick, this is a great question. So how do we describe the benefits of a sparse search versus using sparse indexes compared to solutions like Elasticsearch? So I'll go ahead and stop sharing here. I wrote an article on how the Pinecone sparse model works compared to typical lexical models. That is a great read and will help you understand the specific benefits of kind of like what is going on here. So I'll go ahead and send that article there. But specifically, what is going on is that the sparse model is going to do a space-based tokenization. So if you have some query and you want to preserve a precision-based search where you really care about the keywords being used, but sometimes you'll use keywords in a way that is still ambiguous as to what they mean in what context. And you want to use the chunks that you've embedded or the documents that you embedded, the context of how those words are being used inside your database in order to inform what documents should be returned. The sparse model keeps that in mind and conducts a calculation in order to return the documents that are relevant given the keywords that you're searching. Basically, there is an intention-based operation that happens with the sparse model that reweights the importance of the words used in the query in addition to how they are used in the documents in order to be like, oh, you care about the word bear. But when you're using the word bear, we're going to look for documents that have the word bear, but we're going to care about the word bear being used in the context of like natural parks, right? Nature parks, basically, not in the context of like things that are really heavy that you can't really like bear that thing. It's a very simple example, but it indicates where you can do keyword search. You'll return words that have overlap with the query that you're actually using, but it won't return understanding. The sparse model will return keyword overlap and understanding, which is when it's really useful. Venugopal is asking about knowledge bases. We have 1 terabyte of knowledge base in our company. Would it be possible to bring agentic capabilities to answer any questions employee has? Yes, it is possible. I usually recommend developers to start with semantic search and exposing that directly before you go up to agentic because you're going to be creating you really want to understand the nature of your queries before you start building tools that assume the nature of your queries. So in this situation, what you could do is take in a user question, use an agentic operation to break down that question into sub-questions, query all those sub-questions, re-rank them, and return them. That's kind of like the workflow you want to do in order to make that a little easier to operate. Let's see what else we got here. Val, I tried using Pinecone with TypeSense. Can we achieve semantic or hybrid search without using TypeSense for our marketing website? That's a really good question. I'm not really sure. I've never heard of TypeSense, so maybe it's an integration that they have that supports what Pinecone does there. Vaughn is asking about audio vector embedding models with our integrated model. So I have a previous webinar that I've done with Anthropic where we used our old YouTube videos, transcribed them, embedded them all with text, and then searched over them to kind of replicate a multimodal search. So that might be really interesting to you. So if you search contextual retrieval with Anthropic and Pinecone, that'll be what'll be helpful to you. I know you've been asking about it, so I wanna help. We're getting to the near the end of the webinar. If you have any more questions, please send them in the Q&A. I'll go ahead and try to answer them as much as possible. Evelyn, you're asking about Pinecone N8N. Again, we don't support that integration, but a lot of people have asked us about this, so we're happy to look into this and kind of help you figure out what's kind of going on. I'm not sure about the specifics here. Besides Cursor, Claude Code, do you use other MCP clients to test Pinecone's MCP server, like a JavaScript or TS framework? I know we have a JavaScript example in our documentation, I think, well, for our release post that my coworker Malen wrote. I'm going to go ahead and send that to you here. Yeah, there's a JS example here. So let me send this to you, Mike. Great. Through. Can you give examples of creating agentic sub-questions? Sure. So maybe someone is asking like, hey, how do I get started using Pinecone? And that's the query that they pass in. Sub-questions for that could be, how do I install Pinecone? How do I find the Pinecone quick start? How do I upsert data? How do I embed data? All of these things are things that are related to the user's intention that you could query individually and independently in order to get the information that you need. A very difficult thing that happens with a lot of people building search is that they'll have queries that are super vague, and then they'll be like, why aren't these good results being returned? It's because your users are not using the queries that you're kind of expecting. Thank you, Venugopal. That's very kind of you. I really appreciate that. I'll go ahead and answer this. Upcoming features. We got some stuff. I'm pretty excited about figuring out how to tinker more with these integrated code environments, Tim, in order to see like what's the best possible way of using Pinecone while I'm coding. Like I want to have that optimized rules file. I want to have that optimized MCP interaction. I'm still thinking about what that should look like, and I'm hoping to hear from you all on what you'd want, so we can kind of focus on that. Okie dokie. I think that's basically everyone. In terms of use cases, Geraldo, what's the most immediate you would say I can start experimenting on with my organization? I always recommend everybody to start with semantic search. What that means is you're going to index your information that typically is not easily indexable, like maybe it's inside PDFs or whatever, and then you're going to make it readily available for you to ask natural language questions over. That's going to be like really mind-blowing for many applications. One of the first applications I built at Pinecone was multilingual semantic search using the same embedding model for multiple different languages. And it was amazing how I could just like type sentences that would have no overlap for sentences in other languages and return those sentences that are actually relevant. So Gerardo, I would recommend doing semantic search, monitoring the kinds of queries you're kind of seeing within your organization, and then building in retrieval augmented generation if there's a specific task that your organization is trying to solve that relies on those search results. But iterate on the search first before you do everything else. Semantic search is the word for the mechanism that the agentic search is doing. So the semantic search is your queries you're passing that are being embedded in their entirety, like using a dense embedding model and not looking at like the word overlap, you're looking at the meaning of the sentence. Agentic search is like telling a model to do the semantic search for you in order for it to find the optimal results for you. So when you don't do like query engineering or you don't do query expansion or understanding to figure out what the user needs, you pass that along to another model, that's agentic search. You want to build a triage agent for SOC. What strategy would you recommend? This is a great conversation to have with our field engineers, but I'll give you an idea. If you have multiple clients with their own knowledge bases, but let's say each of those clients are at the same organization, so you have a lot of users, you can use something called namespaces, which will let them live on like a multi-tenant architecture on your index. So you can just query within those namespaces when you need the user's information and still get the benefits of kind of like scaling up and down on your architecture. But I don't have the entirety of the time to like fully answer your question, but that's where I would start, Gabriella. I appreciate your patience. Any framework for semantic search? Streamlit's great, Gradio's great, whatever floats your boat. Whatever is easiest for you. I really like Streamlit, but that's not for any specific reason. I just use Streamlit because it's there. Can Pinecone be used to index images? Yes. You cannot store the images in Pinecone. You can store the embeddings. So what that means is that you can embed the images, they'll turn into vectors, and then you can just search across the vectors if they were any other vectors. And that's like pretty easy. Awesome, everybody. We do have an upcoming webinar pretty soon. Jenna, if you could throw that link in the chat. We will be having that webinar on September 25th. Please click it and register. We're going to be going over how to secure our RAG pipelines with fine-grained authorization using SpiceDB. So Gabriella, that might be something that's interesting to you if you're trying to kind of segment your users there. If you have any questions about how to use MCP, if you really want specific requests, please let us know. My name's Arjun. You can find me on LinkedIn or you can find me on the Pinecone community. I'll be more than happy to answer your questions, kind of help you think about these things. Really appreciate everyone's attendance. I hope you had a wonderful time and I hope you learned something new.